Alright, we're talking about inverses, and I know that sounds like something you haven't heard of before, but it's not going to be that bad. What you need to know is that the inverse function is reflected across y equals x. In Math 2, when we talked about transformations, one of the things we transformed was functions reflected about y equals x, and this is what it looks like, okay? The dotted line here is y equals x, so that's the line it's reflected on. If you fold it on that dotted line, you would get the same thing on both sides. So one of these functions is y equals f of x. The other one is the inverse, and we write the inverse with a -1 power, kind of like that. That's just the notation for it. If a problem says to find f with a -1 of x, that means find the inverse. Okay? So some problems that you would have related to this, first of all, are like if you just have some points or if you have a table. To find the inverse, all you do is switch x and y. If it's a graph, then after you switch x and y, you're going to graph the new points. But if it's just points, all you're going to do is you're going to switch them. Okay? So on this first problem here, find the inverse of these, all you do is you switch it. 2, 1. Instead of x, it's y. Instead of y, it's x. So you just switch them. -1, 4. 0, 5. And 5, -2. So when you have a list of points, you just switch them. When they are in a table, again, you just switch them. Okay? Instead of 1, 7, it's going to be 7, 1. Instead of -2, 3, it will be 3, -2. Instead of 5, -1, it will be -1, 5. All right. So as far as a graph is concerned, it's the same process, but you have to first figure out what the points are. So in number 3, like they have some points drawn for us. So first, let's write down what those points are, and then we're going to switch them and graph the new ones. Okay? This point is 0, 3. This point is 2, 0. So if I switch them, just flip-flop them, I would have 0, 2 and 3, 0. And now I'm going to graph those points, those ones that I just flipped. So 3, 0 would be here. 0, 2 would be there. And then you just connect them. And when you do that, what's supposed to happen is that line that goes down the middle of it, it should just be like reflected on it. Or if you fold it on it, you get the same thing. That sort of makes sense, especially if you turn your head a little bit sideways, you can see that it's the same thing if you flipped it across there. Okay? You need at least 2 points. If you can come up with more, that's great. If you can't, that's fine too. So number 4. They don't have any points drawn for me, but I'm going to go ahead and pick some. So maybe that point right there would work. That point right there would work. I'm just looking for points that go through like the grid there. So I'm going to use those 3 that I just highlighted. Alright, that looks like we have a point here of -2, 0. We have a point here of 0, 4. And a point here of 2, 8. So then I switch them and I graph the new things. So 8, 2, 4, 0, 0, -2. And now I'm just going to graph those 3. So 8, 2, 4, 0, 0, -2. Connect those points. And that's the inverse. All right, I've got one more graph to look at. And it's kind of hard to tell here, but I think there's supposed to be a point here at 0, 1. And I think there's a point up here at 2, 4. Like I said, I know that's hard to see, but I'm just gonna tell you that's what the points are and use those 2 points. Switch the points again. So 4, 2, and 1, 0. This is written by 2, so 4 would be out here and 2 would be here. 1, 0 would be here. And this one, instead of making a line, I don't make a line, I have to curve it since this is curved a little bit. Okay, so I just have to sort of curve it a little bit, kind of like that.